Today we are going to continue looking at our properties with polynomials. So we're going to talk about multiplying polynomials today. And remember, the rule says that when we are multiplying and exponents are involved, we add the exponents. So that is still the case here. I just want to give you the reminder that if we have something like 4x squared times 3y cubed, we've sort of struggled with this with some of us in thinking that we can't multiply them, but that's not the case. These can be multiplied together. Doesn't matter that the base doesn't match, right? We'll just take 4 times 3, which gives us 12. It's just that we can't add the exponents. So the bases are different, so they just come along as two separate pieces. And that just becomes a 12x squared, y to the third. So we want to look at this with polynomials today. So the first one we're going to look at is going to be a monomial, right? One term times a trinomial. So 2x squared plus 3x plus 1. Okay, so hopefully we recognize or remember that parentheses tell us to distribute. And so we're going to take this 6x and we're going to start passing it out to each term. So I'm going to do 6x times 2x squared, right? Ignoring these over here. So 6 times 2 gives me a 12. And then this x really has a 1 on it. So 1 plus 2 is 3, and I'll get 12x to the third. Then I'll go to the next piece. Okay, and I'll kind of ignore these two inside pieces. So 6x times 3x. Well, 6 times 3 gives us 18. We'll add the exponents. So a 1 and a 1 gives us 2. And then we'll go to the last one. So a 6x times a 1, well, that just gives us a 6x. Now, we can't add or combine any of these terms because they don't have matching exponents. So this is just our answer. 12x to the third plus 18x squared plus 6x. Now, these can get a short, long, complicated, whatever. The nice thing about polynomials that we've said over is they might take us more time, but the rules don't change. So let's say we have something like 4a to the third times 2a squared plus 5b. Okay, so we're going to start distributing. So what will 4a to the third times 2a squared be? We should say 8a to the fifth, right? We're adding those exponents. And then we'll go to this next piece, but now be careful, right? So 4 times 5 is 20, but these don't have matching bases, so that a to the third and b just come along. So we get a to the fifth plus 20, a to the third, b. Okay, we could have something that looks totally crazy, like 2x to the third, y to the negative 1, times 5x squared y to the third, plus 2x squared y squared, minus 4xy. Now, I would suggest on this one that you do all the distributing first and deal with the negative exponent last. It's just going to save you work in the long run. Okay, so if we start distributing here, 2 times 5 gives us 10. Right, we have x's that can go together, so 3 and a 2, we add those, gives us 5. And then when we add negative 1 plus 3, that gives us a 2, and we don't have to worry about the negative exponent on that one anymore. Okay, then we'll go to the next one. What's our second term going to be? We should have said 4x to the fifth, y. Okay, and then we will go to our last term. So 2 and a negative 4 give us a negative 8. X to the third and x gives us an x to the fourth. A negative 1 and a 1 give us 0. So that's just times 1, which we don't need to write down, so the y's cancel out. We don't have any negative exponents left, and that is our final answer. So again, while some of them might take a little bit more time to do, they don't require us to learn anything new. We're just taking those properties of distributing that we already knew and combining it with our exponents. Now, let's say we take this a step further, and now maybe we want to do a binomial, so something with 2 terms, times another binomial. So now we have 2 terms times 2 terms. Well, the good news is the rules don't really change. Okay, and so what we're actually going to do is think about this as distributing twice. Okay, so we're going to look at this first binomial and we're going to cover up this second term and just start distributing the x. Okay, so x times x, right? Remember, we add the exponents. So x times x is x squared. X times 4 is a positive 4x, right? And that's just distributing like we already were doing. Now, what we're going to do is just sort of switch which term we're looking at. So now I'm going to cover up the first term. Don't cover up that addition. It tells me that 7's positive. And now I'm going to distribute the 7 to both pieces. So 7 times x is a positive 7x. Now, we could write plus 7x next to this. I kind of visually like to write a plus 7x underneath the 4x because those are like terms. I'm not writing it under the x squared because x and x squared aren't like terms, but x and x are. So then I'll do 7 times 4. That gives me 28. It's not a like term, so I'm putting it over here on the end. Okay, so I distributed 1, 2, 3, 4. I have 1, 2, 3, 4 pieces, but we're not quite done yet because we still have to take care of combining like terms. Okay, so I'm going to combine my like terms, and now I have that nice stacked look that we liked with addition. 7 plus 4 gives me 11. Remember, the exponent stays the same. And so my final answer will be x squared plus 11x plus 28. Now, this process that we just did is really multiplying a binomial times a binomial. But just so you know, this is often referred to as FOIL or foiling, sort of like PEMDAS is now order of operations. It's an acronym that stuck so well. So this really stands for first, outside, inside, last, which just helps you to remember what terms to multiply. So don't be surprised if in textbooks or conversations, math teachers, I do it, you might hear the word FOIL, which is just the same thing as multiplying a binomial times a binomial. Okay, the problem is that FOIL doesn't work all the time. Thinking about distributing always works. Okay, so let's look at this next one. Let's say we have 2y minus 5 times 3y minus 7. So again, we have a binomial times a binomial. So we're going to think about distributing just in two different chunks, right? So I'm going to ignore this right here and start distributing my 2y. So 2y times 3y gives me a 6y squared. Okay, now again, still ignoring this. 2y times a negative 7 gives me a negative 14y. Now I'm going to switch. Okay, and now I'm going to go to my second term. Don't cover up this subtraction. It tells us that it's negative. Okay, so if I do that, negative 5 times 3y gives me a negative 15y. Where might I want to write that? Right underneath this negative 14y because they're like terms. Then I can do negative 5 times negative 7, which will give me a positive 35. Now, I'm not done yet. What do I still have to do? Right? I still need to combine those like terms. I still need to add them. So we let a 6y squared. Negative 14 plus negative 15 will give me a negative 29y plus 35. And so my final answer is 6y squared minus 29y plus 35. Okay, so we're going to look at one more here. Same process. 3a squared minus 1 times 5a plus 2. So same process, but a little bit of a different outcome here. So let's take a look here. So what are we going to start distributing first? Right? We want to distribute that 3a squared. So 3a squared times 5a is going to give us a 15a to the third. Okay, we're going to take 3a times 2, which will give us a positive 6a squared. What are we going to distribute next? Right, next we want to distribute the negative 1. So negative 1 times 5a gives us negative 5a. Where might we want to write that negative 5a? Right? This isn't a like term with anything else. So underneath these two places is not a good pick. So this one doesn't end up having a like term and it just starts its own piece. So we just kind of continue. Negative 1 times 2 gives us a negative 2. We do not have any like terms to combine here. There is nothing else for us to put together. And so our final answer is just all four of these. 5a to the third plus 6a squared minus 5a minus 2.